whoever else might be out today. All right, so Unit 2, Day 1, recording on August 18th. Average rate of change and the definition of derivative. Average rate of change, I hope you know that, right? That was a bonus on yesterday's test, or Wednesday's test, and like half of the test in pre-cal last year. Like the bonus was find the average rate of change for whatever. And the reason is average rate of change becomes, it's not equal to the derivative. It's definitely not the derivative. But with some work, we can turn it into the definition of a derivative. So let's remind ourselves what the average rate of change is. Sometimes we'll abbreviate it as AROC. Be careful, that's not like a universally accepted definition. So don't, or abbreviation, don't use that on the AP test. But I'll know what you're talking about. And again, it's just good old Algebra 1 slope. However you want to remember that. Change in y over change in x. y2 minus y1 over x2 minus x1. If we want to get fancy, we could say the change in f, change in the function value over the change in x. So f of b minus f of a over b minus a. That looks a little fancier, but it's still the same thing. It's just change in y over change in x. I guess we could back all the way up and rise over run. First talking about slope. Okay, so there's our Algebra 1 lesson, although we'll practice a couple here. Find the average rate of change of f of x equals 4x squared minus 9 from -1 to 3. So find average rate of change. So delta y over delta x. I have my x's, I need my y's. So I'll find f of -1 and f of 3. And then I'll have my y values, I'll have my x values, and then it's Algebra 1. I mean, arguably it's Algebra 1 now, like just plug in -1 and see what you get. 4 minus 9, -5. 4 times 3 squared minus 9. So a little bit harder. 9 times 4 is 36. Minus 9 is 27. And it doesn't matter which one you call A or B, which one you call 1 or 2, just as long as you keep things consistent. So I'm going to do 27 minus -5. But that means I need to do 3 minus -1. Again, order doesn't matter, but make sure the order is the same. So I guess your first order doesn't matter, but then the bottom one has to match it. 32 over 4 equals 8. Oh, and I guess we could have safe stopped back here. And I know some of you were using the safe stop stuff on the test, and that is fine. It's encouraged. It's not just fine. It's you should, right? You probably should stop here, just in case you mess that up and do 27 minus 5 or 3 minus 1 equals 2, or or reduce wrong. You're not taking the cheap way out when you safe stop. You're taking the safe way out, and probably getting more points, or making sure you get all the points. Alan? Yeah. Safe stop is allowed on the AP test. And again, there's only 9 free response questions on the AP test. No, not 9. They're 9 points each. There's 6 free response questions in the AP test. They have multiple parts to them. So there's probably 24-ish free response answers you could give. And some of them aren't really eligible for this. So it's not often you get to use it. But when you get to use it, you should use it so that you don't make some dumb mistake. As long as your answer is equivalent to mathematically equivalent to the right answer, they'll accept it. So like, you really wouldn't want to do this, but if you wanted to reduce that to 16 over 2 and like say, that's my answer, It's right. It's not really the best answer. And if you were going to safe stop, you should have stopped here. If you're going to reduce, you should reduce. But as long as what you write is correct, you're okay. Number 2, same type thing. Find the rate of change, average rate of change. So slope, g of x equals sine 3x from x equals 0 to x equals pi over 9. Why don't you try that one? I'll get it set up, but the problem is not the setup. The problem is the sine of 3 pi over 9, probably. Sine of pi over 3. Sine of pi over 3? Root 3 over 2. So root 3 over 2 minus 0 over pi over 9 minus 0. Obviously, there's a lot of cleanup that could be done, but why bother? Safe stop that and move on. And here's the best part, maybe, is that sine of pi over 3, that's calculator ready, and it's not calculus. So really, you could leave your answer as sine of pi over 3 minus sine of 0 over pi over 9 minus 0. That is also a safe stop. Because it's not calculus. Like we want to check to see if you know calculus. This is not calculus. You should know it, but it's not calculus. So we're not really going to grade it. Or if you don't want us to grade it, we won't grade it. If you want me to grade it, I'll be happy to grade it for you.
Like, what if I safe stop somewhere that's not a safe stop?
That is the trick, is like getting a little aggressive on your safe stop. You can't, what would not be okay is to leave it as f of pi over 9 minus f of 0. Like you can't leave it in function notation. You have to do the substitution. Yep, that's right. This is even reduced one more. You could leave it as sine of 3 pi over 9. Again, don't get too excited because most of the time problems that are this simple and straightforward are going to be multiple choice questions. So you're going to have to reduce 3 over 2 times 9 over pi would be 9 root 3 over 2 pi. So there's my multiple choice answer. But hey, if you don't have to do it, don't. All right, definition of a derivative. Let's draw some curve, f of x. Let's pick 2 points on that curve that are kind of far apart. So the y values would be f of x1 and f of x2. And if we wanted the average rate of change, between those 2 points, just be f of x2 minus f of x1 all over x2 minus x1. That's not a derivative yet, that's just average rate of change. We're going to make some substitutions to make this look like a derivative. Let's say this distance from x1 to x2, let's just call that delta x. That's our change in x. And that's equal to x2 minus x1. So now we could rewrite this AROC thing as f of, well, x2 now is, I could rewrite x2 as x1 plus delta x. This feels a little bit weird maybe because like what's wrong with this? And the answer is nothing's wrong with that. I just want to change a few things to make the next couple steps easier. So in place of x2, I'm going to say that that's x1 plus delta x minus f of x1 over delta x. So now everything's in terms of x1 and however wide our delta is, however big our step is. So you know what? Instead of calling it x1, let's just call it x. F of x plus delta x minus f of x all over delta x. I'll sort of rename some things just to make life easier for my next step. So admittedly, AROC, you would not use this format. Like, why would you do that? Like, you have a formula for AROC. That's algebra 1 slope. We're good. But if we do a little bit of algebra gymnastics, we can land here. So here's my x. There's some delta x that way. But if I let delta x get really, really small, like say go to 0, so my x is still here, but if I change my delta x to be something really, really small, and there's my new line. In fact, this looks like a limit. So I'm going to do the limit as delta x goes to 0. So it's, instead of this average rate of change over this big spot, I'm going to shrink that delta way down to 0. And I'm still going to leave, this is still going to be the same. So it's still the same formula, f of x plus delta x minus f of x over delta x. So that's not really an average rate of change anymore because it's not all this over this whole span. It's like right next to it. In fact, it's not really average. It's more of an IROC instead of an AROC. And guess what the I stands for? Instantaneous. This becomes an instantaneous rate of change. Maybe overkill to write it again, but you're going to have to know that formula. So writing it again, helps it stick in your brain. So that green line is not an average rate of change. It's an instantaneous rate of change. In fact, it's the slope at a point, which is kind of weird. You were never able to do that in algebra because algebra you had to have 2 points to have a slope, right? You can't have slope at a point. That doesn't really make sense. Except in calculus, you can say, well, if I let this shrink down really, really small, then it is kind of the slope at a point. It's not between those 2 points anymore because that distance shrunk down, so it's the slope at a point. Now, all of these are different ways of saying, turn the page, what we just sort of backed into is the definition of a derivative. So what we just wrote is the definition of a derivative. Super important. You have to know that and use that to find some derivatives. People always ask, do I have to memorize that? I'm like, well, you have to know it. I hope you understand where it comes from. And you understand that it's just it's basically limit as delta x goes to 0 of a rock equals I rock, which is the derivative. So none of you seem as excited as you ought to be that we just found the definition of a derivative. And it's really not that big of a deal. It's just, it's algebra 1 slope. But instead of dividing by x2 minus x1, we shrink that all the way down to 0, and then we have to take a limit because we can't divide by 0. So we're going to have to use those algebra tricks that you did on the test where 0 is in the bottom. So you're going to have to do all those algebra tricks again in order to get a derivative. So we'll still be doing limits, but instead of just like abstractly doing limits, we'll be doing limits so that we know the derivative, the slope of a tangent line. I rock, slope at a point, slope of a tangent line. These are all different words. We'll use these different words to mean derivative. And we'll intentionally try to ask them different ways to make sure you understand that it's really all the same question. Find the average, find the instantaneous rate of change, find the slope of a tangent line, find the derivative. It's all the same thing. Notation, so just different ways to write the derivative. There's lots of different ways to write it. They're basically interchangeable. It kind of depends on the situation as to which one is preferable. And you don't really have to like memorize which way to go because they're interchangeable. Just as you do more and more calculus, you'll learn sort of where it's helpful and where it's to use which one. The derivative of y with respect to x, so that's sort of like the change of y with respect to x, but it's not a delta, it's a difference, so we use dy dx, which is the same thing as this one. We use this prime, y prime is what we say, y prime of x, or just plain old y prime. Speaking of algebra 1, y and f, those are kind of interchangeable, right? F of x is the same thing as y. And so everywhere there was a y, we could put an f. So all of these mean the same thing. So that's 8 different ways to say the same thing. All of those mean derivative. So they are interchangeable, but you do have to use the correct notation. So you got to use one of them and understand them. And you can just see on these first 2 examples, the first one we ask for g prime of x. The second example we ask for dy dx. But that's the same thing. So that's just a little bit of test to make sure you know that those mean the same thing. All right, given g of x equals this, find g prime of x. Okay, well, I'm going to start with g prime of x, and then I'll worry about finding it, putting the pieces in. So limit as delta x goes to 0, g of x plus delta x minus g of x all over delta x. That's the definition of g prime. So g of x they gave me, so I know that. Delta x, just another variable, I know that. What I need to find is g of x plus delta x. So this is algebra, but it's kind of a pain algebra, right? Whatever's in parentheses has to go in for x on the other side. So 3 times x plus delta x squared minus 2 times x plus delta x. So let's see, this is going to be lovely. Trying to think how many steps do I want to skip. Probably not many the first time through. Let's FOIL x plus delta x. That would get us x squared. I am going to skip the write it out FOILing step. If you're made it this far in your math life, you should be able to FOIL that without writing out x plus delta x times x plus delta x, and then writing out FOIL and filling in the pieces. Like, we should be beyond that. Do it if you need to, but I'm kind of expecting you to be able to do that. So there's the F term. The O and the I would be x delta x, so there'd be two of them. 2x delta x plus delta x squared. I'm going to put a parenthesis around that to make sure we understand that we're squaring the delta x. Minus 2x minus 2 delta x. Let's distribute the 3. 3x squared plus 6x delta x plus 3 delta x squared minus 2x minus 2 delta x. Oh. And that's not even my answer, right? That's just what is going to go right there. So now I'm going to rewrite my definition of a derivative, and instead of just writing g of x plus delta x, I'm going to write all of that stuff in there. So g prime of x equals limit as delta x goes to 0 of all of this stuff, 3x squared plus 6x delta x plus 3 delta x squared minus 2x minus 2 delta x. All those years of your math teachers telling you to show your work, don't skip too many steps. The more work you show, the better off you'll be. Well, all that's still true. Minus, again, that was just g of x plus delta x. Now I need to subtract g of x, which was all of this stuff. 3x squared minus 2x. And all of that over delta x. I need to have my calculus is easy, algebra is hard stamp inked up and ready to go for this unit. I'm not going to take, speaking of showing steps, I'm not going to write a whole nother step where all I do is distribute the minus sign. I mean, you can if you want to, but let's be better than that. Let's look for like terms. So 3x squared, does that have anybody to combine with? All of the rest of this junk? Yes, it'll cancel with the 3x squared, so that's kind of nice. Let's see. 6x delta x. So I need another x delta x if I want to combine, but I don't see anything. Delta x squared, I don't see any delta x squareds. 2x, does that have any friends to join with? It cancels, good. That minus sign, we didn't want to take the time to show the distribution, but it distributes, making this positive 2x, which cancels with the minus 2x. And we're getting close. This is a spot where people start skipping steps, but I'm not going to do it just yet. So what's left is 6x delta x plus 3 delta x squared minus 2 delta x all over delta x. Oh, this is good. This is good. What's good? What am I excited to see here or do next? Everything has a delta x in it. So I can cancel a delta x. Be careful. That one's got 2 of them, so we need to be careful right there. Limit as delta x goes to 0 of 6x plus 3 delta x, because we canceled one of them, minus 2. Okay, what's our first go at gave away the answer. Our first go when we want to evaluate a limit is substitution. Well, that's an easy substitution. If I put in delta x equals 0, then it wipes out that term, and my answer is 6x minus 2. And all of that was to find the derivative of g. Right? Calculus is easy. Algebra is hard. Where's the safe stop? Well, those are good questions. We have to do this every time. And where's the safe stop? Let me go in reverse order. There's not really a safe stop till you get here, because that's calculus stuff, right? You can't safe stop calculus. They made it. You can't safe stop calculus. You got to keep going if there's more calculus to do. Here's the notes. So there's not really a safe stop in this problem. Maybe there's one later where you could safe stop a little bit, but you're still gonna have to do all the algebra. Alan's question was, do we have to do this every time? The answer to that is today, yes. Monday, no. Okay. As always in a math class, right? It's like we teach you the long way, and you drill the long way forever, and then you come back the next day or 2 days later, and the math teacher's like, hey, remember that thing that took half a page to do? Yeah, today there's a really easy shortcut. So there's a really easy shortcut coming, but not yet. And I don't say that just to be mean as a math teacher, and because we always do it that way with math teachers. The AP test can ask questions in such a way that force you into this. They have their ways that, usually you'll use the shortcut, but they can ask questions that sort of force you to do this. All right, speaking of safe stops and does it take everything, look at the way the next question is worded. If y equals 1 over x plus 1, write the limit expression for dy dx. Like the limit expression, I feel like that suggests I don't actually have to find the limit. I can leave it as a limit. So that'll save me a little bit of work. Also, one more comment on this definition up here. A lot of times it's painful and annoying to write delta x over and over again. So a lot of times we'll use h instead of delta x. It means the same thing, it's just easier than writing delta x. So dy dx, I'm going to switch to h this time because it's easier. Limit as h goes to 0. Okay, we got y, so I'll write it as a y. Y of x plus h minus y of x over h. Okay, right, the limit expression. Okay, well that's sort of right. That is a limit expression, but usually it's not a safe stop until you plug things in. So I do probably need to find y of x plus h. So that would be 1 over, place of x goes x plus h. So 1 over x plus h plus 1. So limit as h approaches 0, 1 over x plus h plus 1 minus y of x, which is just 1 over x plus 1, all over h. The directions say write a limit expression. I think that looks like a limit expression to me. So we can stop there. The AP test would test that by making that a multiple choice question, basically. That way, even if you knew how the shortcut worked, you'd have to do the definition to get it to look like that. Do you know how we would clean that up if we wanted to go further with our algebra? We had problems like that on the last test. You used the fraction thing, so I'd have to multiply through by x plus h plus 1 and by x plus 1. And so that would be a calculus yucky situation, which is why we said write the limit expression, don't finish the problem. All right, alternative form of the definition of a derivative. Let's kind of do the same type picture. But this time we'll use a and x. And the process is going to be pretty similar. We'll start with an A-rock problem. So A-rock is no limits involved at all. It's just good old algebra 1 slope. A-rock is algebra rate of change is another way to say it. That's not the official way to say it, but that A means average, but you can also think it means algebra, so that you're not doing calculus, you're just doing algebra. So change in y would be f of x minus f of a over x minus a. And we should have backed up and said, the alternative form is going to tell us not what f prime of x is, but what f prime of a is, meaning the derivative at a certain point. At x equals a. So a is sitting there, and I'd like to find the derivative at a. So I'd like to find this like tangent line slope right there. So I want to hold a in the same spot, but I want my tangent line, I don't want it to be this algebra rate of change way over there. I want an instantaneous rate of change. So where do I need to move? Where does x need to go? If I want that difference to shrink down to 0, where should x head toward? I don't want it to head to 0 because that would put it all the way over here. Let's let it head toward a. And heading toward a, that's a limit thing. So the limit as x approaches a, and then it's just the algebra slope, except that we're letting x go to a. So that becomes our instantaneous rate of change, but at a certain point, at a specific point. So that's the derivative of f at a. So that's a separate but related formula that we need to know. There it is, boxed in. The confusion is not how to use them, but when to use them. Like, how do I know if I need to use the alternative form or the other form? Alternative form tells you the derivative at a certain point. The definition of a derivative tells you the derivative at any x. So this bigger definition is more robust, it's more powerful, more helpful. Like that first example we did, you can now find the derivative of g anywhere by just plugging in whatever value of x into 6x minus 2. The alternative form is going to be a little bit easier to mess with, but when I do this example 1, I'm only going to know the derivative at 2. I'm not going to know the derivative everywhere. So the process is quicker and easier, but your answer is a little bit more limited. So f prime at 2 means the limit as x approaches 2, f of x minus f of 2 over x minus 2. So it's similar to the definition. I will use f of x. I need to find f of something. It's probably easier to find f of 2 than it is to find f of x plus h. So students usually like this one better. It's easier. But again, the downside is it only tells you the derivative at 2. It doesn't tell you the derivative everywhere. And maybe that's fine. Like this problem just wants the derivative at 2. So why do the hard one? Do the easy one, even though it only tells you the derivative at 2. So let's see. 2 times 4 is 8, plus 8 minus 3 is 13. So let's start plugging things in. F of x, it gave to us. F of 2 is 13. Right, that's a whole lot easier than f of x plus h. Because we would have had to square x plus h and have 4x plus h, and that's where we would have had that really long. We don't have to worry about that. F of 2 is 13. I guess I'm supposed to try substitution, but I can see right away that from the get-go, I'm going to have a 0 in the bottom. So something's not quite right here. Let's see if we can clean this up a little bit. Let's see. Factor out of 2. Hope your factoring skills are good. Factor what's left. Although, kind of a built-in hint, I'm pretty sure x minus 2 is going to be one of the factors because I really want it to cancel. So x minus 2 and x plus 4. X minus 2. That's great news. I can cancel the x minus 2's. Officially, of course, I've been writing a limit as x approaches 2 in front of every single step. Now we can substitute 2 times 2 plus 4. Safe stop if you want, but by now, it's like, well, I'm almost there. And I just say the answer is 12. Now let's recognize what we've got here. That's the instantaneous rate of change at x equals 2. It's the slope of a tangent line at x equals 2. It's the derivative at x equals 2. And we like to ask those questions all the different ways to make sure you understand what we're asking. Example 2, write the limit expression. Okay, so that means we sort of got a built-in safe stop here. I don't need to evaluate the limit. Write the limit expression for the instantaneous rate of change. Okay, so that just means the derivative of y with respect to x. Oh, I guess I could use dy dx at x equals 3. So y prime at 3 is the limit as x approaches 3, f of x minus f of 3. Again, the body of the limit is just an algebra 1 slope thing. F of x minus f of 3 over x minus 3. Not quite a safe stop because I need to plug in for functions. So f of x I know, Or I guess I should just say y I know. F of 3 I need to figure out. That shouldn't be too bad. Cubed is 27, times 2 is 54, plus 1 is 55. 2x cubed plus 1 minus 55 all over x minus 3. I guess that would suffice as a safe stop. I want to go one more step. Limit as x approaches 3, 2x cubed minus 54 over x minus 3. Now we're going to stop there because of time and because that said where to stop. That's a limit expression. I don't need to go any further. I hope you can peek ahead and see that you could factor out a 2. That would leave x cubed minus 27. And then you could factor x cubed minus 27 into something. And the x minus 3's would cancel. And then you could get an answer. But that's algebra steps down the road here. All right. That's a lot. Worksheet 1. Shortcuts coming soon, Alan, but not yet. Not yet.